So in step 1, we have to find fx. E to u is e to u times u prime times, we are differentiating with respect to x. 2x minus 2, nothing, nothing, nothing. Nice. Fy is e to all that times, we differentiate with respect to y. No y, no y, 2y minus 4. Good, nice. In step 2, this cannot sit the way I wanted it to sit. Stay there. Okay, so fx equals 0 and fy equals 0. I'm not going to even involve this because this is never 0. I don't even want to spend my time writing it. It's just this. 2x minus 2 equals 0 and 2y minus 4 equals 0. Sorry, I forgot to turn off the volume. Okay, so from here I have x equals 1, and from here I have y equals 2. Cannot be easier so far. Good. So that's our question. We don't know what this is because I have to conduct the d-test to show what this is. Okay, so I have to find fxx. Okay, so this is a little more complicated because I have a product and I have to be very careful. So when I differentiate this, I get e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime with respect to x, but it's the same thing. So it will be times 2x minus 2 squared plus all this times this prime, which is 2. 2 times e to x squared minus 2x plus y squared minus 4y plus 2. Fine. Now I want fyy. Okay. Again, the same thing. This prime times this will be this squared. So e to x squared minus 2x plus y squared minus 4y plus 2 times 2y minus 4 squared plus this with respect to y, which is 2. So plus 2 times all this. E to x squared minus 2x plus y squared minus 4y plus 2. I don't have to do anything with this, just plug it in. So I just have to be careful plugging it in. So the last one I need, fxy. So now, careful, I'm differentiating this with respect to y. But this is a constant. It doesn't have y in it. Right? So I only differentiate this, and when I differentiate this, I get the again with respect to y now. So let's write it. It's better to write it first. So this is a constant, will stay in front. E to this prime is e to that. Times this with respect to y. Nothing, nothing, 2y minus 4. And the other one will be the same, so anyway, I don't need it. Okay, so d for 1, 2 will be fxx at 1, 2 times fyy at 1, 2 minus fxy at 1, 2, everything squared. Okay. So now, careful. Careful, 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 because the only thing is to be careful when we evaluate at 1, 2. Okay. So I'm going to do it in 2 steps. E to, this is 1. 1 minus 2 is negative 1. I'm plugging in 1, 2. 1 here, 1 here, 2 here, 2 here. So 1, 1, 2, 2. So 1 minus 2 is negative 1, but negative 1 plus 4 will be 3. 3 plus 2 will be 5. 5 minus 4 will be 1. So e to the first power times 2 times 1 is 2. 2 minus 2 is 0. Okay, awesome. Now plus 2, and I already calculated this is 1. So it's 2e, is it? Let me do this one more time. So 1 minus 2, indeed, minus 1, and 4. So it's 3 plus 2 is 5. 5 minus 4 is 1. Good. So this is 0, so this will be a positive number, times. Now I will evaluate fyy at 1, 2. This is still e. 2, this will be 0, so this is still 0. So this will be 2 times e again. Okay, minus. When I plug in 1 comma 2 in here, this is 0 and this is 0, the whole thing is 0. Okay, so this is definitely a number greater than 0, because 2e times 2e will be 4e squared. It's a number, I don't even care about the number. I just care about the sign. If it's not greater than 0, if it's less than 0, it's a saddle. If it's 0, then it's a problem. The test is not applicable. Okay, so I see that f(x) is positive, d is positive. What do I conclude about 1 comma 2? D is positive, f(x) is positive. What does 1 comma 2 represent?
A min.
Very good, awesome. What is it? I don't know. I have to plug in 1 comma 2 here, but we already did, because we got 1 here with 1, 1, 2, 2. Again, 1 minus 1. 1 minus 2 is negative 1. Plus 4, 3. Yes, I'm checking. Right? I'm checking again 3 times. 1 minus 2. Negative 1. Negative 1 plus 4. 3. 3 plus 2, 5. Minus 4, 1. So f of 1 comma 2 equals e. And that is the relative minimum. How do we feel about the d-test?